Okay, this next video is on section 6.2 in your book. It's on the law of cosines. Okay, again, the law of cosines, just like the law of sines, is a set of formulas that we use in order to find missing angles or side values for triangles that are not special right triangles and triangles that are not right triangles. So we are going to use the law of cosines when we are given 3 side values, or when we have 2 sides and the included angle. So again, you're going to need to have these formulas memorized. Okay, so the first set of formulas are set up in order for you to find the missing side values, okay, because we have our little a's, b's, and c's. The bottom formulas down here would be used in order for you to find the angle A, the angle B, or the angle C. So in order to get these formulas down here, I've just manipulated the formula given up here. To get cosine of A by itself, I would have need to subtract it, B squared, C squared, and then divide by negative 2BC. That's how we ended up here. Okay, when I do this with practice and writing down the formula a ton of times, if you don't have it memorized now, you will have it memorized probably by the end of this lesson or soon after you've started your homework or when you're done with your homework. Okay, so make sure that you do have these formulas memorized. Okay, and again, make sure that you have your calculator with you and make sure that it's on degree mode. So we are going to be using the law of cosines for 2 cases, when we have side angle side and when we have side side side. So 2 sides given to us and the angle in between, or 3 of the side values. Now, there's some tricky things that you need to be aware of when you're using the law of cosines. For your side angle side case, the first thing that you want to do is you want to find that value of the third side. Then after that, the next thing that you should do in order to be foolproof, if you're starting with the law of cosines, I would stick to using the law of cosines, just because when you switch to the law of sines, some funky things can happen. So it's really your preference, whichever one that you like. But the important thing for the side angle side cases is after you find the third side, you want to make sure that you go for finding the smallest angle. And the smallest angle is across from the smallest side value, and the largest angle would be across from the largest side value. Okay, that's a refresher. I actually just taught that to my regular geometry kids. For this case, when you're given all 3 of your side values, you want to use the law of cosines to first find the biggest angle. Then you can finish using the law of cosines preferably, or you would use the law of sines to find the other 2 angle values. Okay, so here's our first example. Triangle ABC, side AB is 18, angle A is 47, and AC is going to be 11. So this is our side angle side case. So in that case, the first thing that you want to do is you want to find your missing side value first. Okay, so we have to find side A. So the formula is A squared is equal to B squared plus C squared minus 2BC times the cosine of 40, times the cosine of A. So that'll be A squared equals 11 is B and 18 is C. Okay, and you would take the square root of all that junk in order to find out what A is, and I would just prefer to do that all first so I don't have to type in a bunch of stuff into my calculator. So our side A is 13.2261. Okay. From here you'll see that our side AC, or that side B, is your smallest side value. So the next thing that you would want to do is you would want to solve for angle B. So we'll use the cosine of B equals so the cosine of B equals 11 squared minus, I'm just going to write A squared because in a second I'm going to store that value right here that we got for A, minus 18 squared over negative 2 times A times C. Okay, so I'm going to store that, and I'm going to click alpha A because it's the value for A. Okay, so C was 18. Okay, so that gives us a small decimal, so I need to find the inverse cosine of that decimal in order to figure out what angle B is. Okay, so our angle B is equal to 37.4638 degrees. Okay, I can add 47 to that, and then take 180 and take away, oops, did not mean to do that. So find that angle C is 95.5362 degrees. Okay, so we have found all pieces of the missing information for that example there. Okay, here is example 2. We have 3 side values given to us. So this is our side case. Okay. Okay, so for our side case, what we want to do is we first want to find the biggest angle value. Our biggest angle here is angle B. So we'll do the cosine of B equals B squared minus A squared minus C squared over negative 2AC. So 12 squared minus A is 5. Okay, so I found the inverse of that fraction there. So angle B is going to be 133.4325 degrees. Okay, and from there, it doesn't matter which angle you solve for. I'm going to solve for angle A next. So 5 5 squared minus 12 squared minus 8 squared over negative 2 times 12 times 8. If I wanted to, I could grab that up there, so I'm just going to write it again. I can grab it up there and then just change around those different numbers. Okay, and then I have to find the inverse. Oops. That answer. So angle A is 17.6124 degrees. Okay, I'm going to take that answer and add it with, I'm going to go up and grab angle B's value. Then I'm going to take 180 and subtract that answer to find angle C. So angle C is 28.9550. Okay, here's another one. It's a side angle side example. So for side angle side, you need to solve for that missing side that you have. In this case, it's our side C. 24 is our side A, and our side B is 30. Okay, so we'll have C squared equals B squared plus A squared minus 2AB cosine C. So 24 squared plus 30 squared minus 2 times 30 times 24 cosine 30. And we would take the square root. So our side value for C is 15.1302. Okay, from there we want to, for the law of cosines, when you have side angle side, you want to go for your smallest angle. Okay, our smallest angle was actually angle C, because it's our smallest side value. So from here, it doesn't matter which angle you solve for. I'm going to solve for angle B. So the cosine of B equals B squared minus A squared minus C squared over negative 2AC. Okay, and I'm going to write C squared here, because right now I'm going to store that long decimal answer so I can use it. A is 24, C. Okay. Okay. Then what you need to do is take the inverse. So angle B is 97.5224. Okay, if I add that with my angle C and then take 180 and take away that answer, oh, what did I do wrong? side C, angle B, angle A. Alright, so here's a word problem that we can use. So pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. How far is the pitcher's mound from first base? So if we drew our softball field, okay, that pitcher's mound is like in front of that diagonal that connects first and third base. Okay, so we actually are going to have a triangle that looks more like this right here. Okay, so what you need to remember is this will be a square, and back from geometry, your diagonals in your square, they bisect these angles over here. So that angle is 90 degrees, so half of it would be 45. Okay, I also know that all of my bases are, sorry, that's not 43. The pitcher's mound to home plate is 43. Okay, the bases are all 60 feet apart. Okay, and we are trying to find out how far apart that pitcher's mound is to that base. So if I just pop out that triangle to make it look a little bit prettier. And if I labeled these the vertices as A, B, and C, what we would need to do is we are trying to solve for that little missing piece of information there. So that's our side A. So A squared would be equal to our two sides that are given to us squared minus 2 times those two sides. Okay, square root it. Okay, so the pitcher's mound to first base is going to be 42.4302 feet. Okay. And the last type of example that we're going to do is finding the area of a triangle given the three sides. So what you need to do is first have this, you need to memorize that formula. The area is represented by the square root of S times the difference between S and one of the sides times the difference between S and another side and times the difference between S and the third side. So what you need to do is you need to find the perimeter and chop it in half. So this S is really half of the perimeter. Okay, so in this case, S is going to be 43 plus 53 plus 72 chopped in half, which is 168 over 2, and that is going to be 84. So if we have those three sides, we can use Heron's formula to find the area. So it's going to be 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. Okay, 1131.8869, we had meters, so meters squared. Okay, so I'm just going to pause right here for a second. Here are 4 examples for you to just think about which route would you start with. Would you start with the law of sines, law of cosines? So here are 4 of the examples. Your homework for this section is going to be page 405, questions 1, 3, 5, 19, 25, 33, and 35. The last, I think it's 2 or 3 questions, are some word problems. So make sure that you try your best in interpreting them and drawing out the pictures, and come prepared with some questions that you would like to go over in class next time. So if you pause this video to figure out which route would you start with for A, B, C, and D, these are the answers down here. So A, you use the law of sines, B, law of sines, and C and D, law of cosines.